Ladies and gentlemen, on behalf of the organizing committee, I extend a warm welcome to each one of you to this year's Urban Mobility India Conference and Expo. We are thrilled to have you here, and your presence is greatly appreciated. And our distinguished session chair for today, Professor Ashish Verma. Professor Ashish Verma is the convener of ISC Sustainable Transportation Lab. He is PhD from IIT Bombay and is currently serving a Professor of Transportation System Engineering at Indian Institute of Science, Bangalore. His research interests are mainly in sustainable transportation planning and policy. He has authored more than 250 research publications. He is the founding and immediate past president of the Transportation Research Group of India. He is also steering and scientific committee member of World Conference on Transportation Research Society and honorary secretary of Indian Institute of Urban Transport India. Thank you. So we'll start with our first presentation. Supriya Bhutani.
One and all. Myself, Supriya Bhutani. I have recently completed my master's from SP Vijayawada, and currently I am working as a transport planner in Arcadis IBI Group. So today our topic of discussion is regarding the traffic noise in Vijayawada city. This is the brief outline of the discussion, and we'll start like at present we all know that with the rapid urbanization, a lot of migration is happening and the population growth is increasing in the urban areas, which is affecting the carrying capacity of the cities, and thus the demand is increasing and existing urban infrastructure is getting insufficient. And all of these leading to the negative consequences towards the environment. And recently government is focusing toward the improvement in the environment, and since 1972 WHO has declared that noise is a third pollutant that is affecting our environment, and from that time until now there is still that research gap is there, where we are not even considered about the noise pollution that is affecting our urban areas and in the cities. And we can see that in urban areas, where because of the road network and because of the city dwellers, the noise annoyance is increasing, and we can see that in the urban areas, through a research it is found that 79% of the annoyance is due to the urban areas because of the transportation. Then this is the base noise level limits that is defined by WHO based on the different land use areas in residential, commercial, and silence and the industrial areas. But the current situation regarding the noise in the cities is increasing rapidly, which is required to investigate and monitor, and also we have to find the solution for the same. For that we have to develop some models so that we can investigate the noise. In various countries like Germany, Sweden, they have developed their convention models based on their city requirement, based on the traffic flow. But as comparatively to Indian condition, where the heterogeneous and the mixed traffic conditions are there, it is difficult to use the same models, and we can't predict the noise through that model. So there are some researchers who have used the various mathematical models. These tools are available, but it again changes with the effect of the various location of the city based on the traffic volume and other conditions. So a comprehensive model is required to develop and investigate the noise so that we can predict the noise and it can be used for the further noise mitigation measures. So our main aim of this study is to understand the link between streamline flow parameters and then the road geometry in the areas and the built environment and noise pollution. For that, the objective is considered first as the to understand about the characteristics of traffic noise, and secondly we will understand what all are the factors that are contributing to the traffic noise. Case area is considered is Vijayawada city, that is second highest city, largest city in the state of Andhra Pradesh, where we have the two national highway crossing from the city, and the major road networks, the urban arterial roads, and other roads having the heavy volume, which is affecting the noise. So, in based on the literature studies, based on the pilot studies, and the traffic monitoring studies that is done before the previous studies, the intersections has been identified in the city. These all are the three intersections that are located on the national highway 16, going towards the Hyderabad, and secondly towards the Guntur. These are the three locations. One is Ramvara Padu Junction, second one is the Mahanadu Junction, and third one is Ben Circle. The methodology that is used for this study, we have done the survey. That is, for 1 week, survey is conducted for 2 hours in the morning, afternoon, and again in the evening. For that, survey is considered the network characteristics, where the traffic volume count is identified. Hierarchy of road is considered about the road inventory survey, and then noise survey is done. There is a noise tool that is used to monitor the noise at these locations, where 1 minute of the noise is considered, and it is identified with the respect of the noise levels at that area. So noise survey is done with the help of that Node Sonic 140 tool, and after analyzing all this survey data, then the descriptive analysis is done among all the parameters, and after analyzing this, the relationship between all the parameters is identified. What is the correlation between all the elements, and then noise level is predicted through that. For doing all this survey, the details are for videographic survey for the TVC volume count, and for number of honks. Honking parameter is considered for the 1 second of the count is considered as one count, and then free movement pedestrian crossing behavior at the road intersections is considered. Through analyzing all the data, this is the result of all the survey findings, where it was found that with the increase of the volume and also with the increase of the honking at the intersection, the noise levels are increasing. That is L equivalent in terms of the decibels. But there is a very surprising result that is related to the speed. Once the speed is increasing regarding like up to the 20 kilometer per hour, the noise levels are increasing, but after a certain period of the time the noise levels are decreasing. And with the queue length that is happening at the intersection because of the signals, first the queue length is varying, and similarly the noise equivalent is also varying with the same. For the speed, another again analysis has been done through Visim micro simulation model. In that, it was analyzed in between the exit and the entrance arm of the junction, and it was found out like at the exit arm, the vehicles have the higher speed, and as comparatively to the entrance arm. And while leaving the intersection at exit arm, once the speed of the vehicle is increased, and after a certain time it gradually decreases.
So Priya, you have 2 more minutes.
Okay, sir. And then after that, peak and non-peak hour analysis has been done, where it was identified there is a 3 to 5 decibel difference in non-peak hours. And through the speed analysis also, again there was a major finding related to 30 to 20 meter per hour. If the speed is decreasing, then there is a lower in the noise levels also. So for the structure equation modeling, the individual constructs have been taken, where we talk about the traffic flow, building built environment, average speed, honking, and road geometry and intersection attributes. So these are the basic latent constructs has been taken, where the all the observed variables have been taken under that, and based on the structure equation methodology, the hypothesis has been constructed, and then after that the mathematical model is developed. With the reference to that, composite reliability and the probability and average variance is defined, so that to understand the basic mathematical model. After analyzing this path and the latent variables reliability, the structure equation model is developed. In that, the direct and the
1
indirect.
minute.
Okay. and the direct and the indirect impact of the each and every variable is find out, and the major effect was the positively from the traffic flow and negatively from the road geometry and the speed. Then another through the special noise mapping is done with the help of the noise mapping tool and the noise tool software. It is found with the distance like up to 46 meter, the noise level is reduced up to 3 decibel, and after again at a 63 meters, the noise level is reduced to more 3 decibels. So based on these studies, it is identified that based on the land use, based on the traffic flow volume, the noise levels are decreasing, and hence it can be used for the further development of the urban areas. Thank you.
Thank you, Supriya, for finishing on time. We have time for a few questions, if there are any, from the audience.
Good morning. I am Subramani Gudge, Chief Engineer in Bangalore Metro Rail. Always this noise is a big issue while constructing major projects. The ambient noise is higher than the permissible limit, and always we are instructed to keep the noise at ambient level when we are constructing adjacent to the road. So my submission is there should be some recommendation or something to allow higher noise level for major projects like metro, etc. One way we tell you reduce the cost, and other way we tell you stop the work for night, don't make the noise like that. So that will help us in reducing the cost ultimately.
Thanks for the point. And from an actual implementation point of view, definitely it's a challenge for agency like yours. But it's a tricky issue because these noise levels are set based on the health parameters, and so some in between way has to be found out. While we try to be cost effective, but at the same time, the impact of consistent noise, higher noise levels on health can also not be ignored from the health point of view. So yeah, maybe more research is required to come out with ways in which noise can still be contained, and yeah, it doesn't lead to much of cost overburden. Thank you. Any other questions from the audience? Okay, thanks, Supriya.
Thank you.
Thank you. Yeah, you want to invite? Yeah, next.
Now I invite Suraj Prajapat on impacts of geometric characteristics on capacity of hill road. Thank you.
Good morning, everyone. So I am Suraj Prajapati, a student of NIT Uttarakhand, and I am standing here to present my topic on impact of geometric characteristics on capacity of hill roads. So come to the firstly on introduction part, capacity. What is capacity? So as we all know that the capacity is the maximum number of the vehicles or traffic volume that a road can accommodate in some within a given time period under some ideal conditions. Now there are so many factors that can influence our capacity. There may be roadway conditions, there may be some traffic conditions, and then there may be some geometrical characteristics also. But in our study, we mainly focus on the what will be the impact of geometric characteristics on the capacity. So our study is mainly on the hilly roads. So on hilly roads, there are some main key geometric characteristics which are present on hilly roads. There is radius of a road, there may be a super elevation, gradient, lane width, and shoulder width. Now, what was the need for this study? In hilly roads, there are so many sharp curves are there. There are so many steep gradients, and change in elevation is there. So we want to see that what will be the effect of these parameters on the capacity. Now the another reason for the study was we want to estimate the accurate value of capacity. so that we can improve our roadways, and we can control the traffic, we can efficient flow, and we can also improvement the safety. Now from these need of study, we choose our objective. Our first objective was to firstly find the capacity, and to find the relationship between the capacity and between the gradient of the road. And our another objective is to estimate the capacity loss. Actually we were studying the hilly roads, so there are curves and straight portions are there. So when a vehicle moves from a straight portion to the curve, there is a capacity loss between there. So we estimated the capacity loss there, and after that we stabilized the relationship between capacity loss, curve radius, and tangent gradient. Now come to the literature review. These are some previous studies that was related to our studies. Now come to next slide, methodology. So this flow chart shows our whole process for our methodology. First we read a lot of literature papers. From there we got idea for our objective, we choose our objective. After that we selected the sites. So we were working on hill roads, so we selected mainly a 4 site between Rishikesh to Badrinath, Rishikesh to Badrinath highway, that was NS7. And we selected site that contains a straight portion, and after that a curve portions. And after that we collected data there with the help of videography method. With the help of videography method, we collected 4 hours data on each site, 2 hours in morning and 2 hours in evening. And after that, collecting the data, we analyzed the data, and we got the values of we got traffic data values like volume from there, and we took. And there's a picture that shows our one of our study sites, and the table shows our geometric data. The geometric data that was taken from DPR, detailed project report. So how we selected our site, and from where we got our geometric characteristics. So this picture shows our one of our study site that was taken from DPR, and corresponding to that site we take the geometric data. Now come to the result part of. So this flow chart shows what was the process for determining the capacity. So from analyzing our data, we find stream speed, volume, and density. And after this, by using the green shield modeling, we find the free flow speed, jam density, and base capacity. So the capacity we found, that was actually base capacity. So, and for finding the adjusted capacity, we applied some adjustment factor from there. So mainly we took 3 types of adjustment factor. First one was adjustment factor for lane width. Second one was adjustment factor for shoulder width, and the third one was adjustment factor for directional split ratio. So multiplying this factor to the base capacity, we got our adjusted capacity. So these are the values for this, and on curve portion and tangent portion. So after finding the capacity on curve and tangent, we plotted the graphs between speed and flows. So there are so these are the graphs on all 4 sides, and the graph contained two types of graph. Like first one is for curve path, and second one is for tangent portion. Now after finding the value of capacity, we established the relationship between the capacity and between the gradient. The gradient values we were taken from our geometric data. And now come to the capacity loss part. So when a vehicle moves from a straight portion to the curve portion, then it reduces its speed, because due to safety purposes. So when it reduces its speed, then there is a reduction between the traffic flow. That reduction is called capacity loss. So we calculated the capacity loss on our sites, and the table shows our values of percentage capacity loss. Now after finding the capacity loss, we stabilize the relationship between the first graph shows the relationship between capacity loss and radius, and the second graph shows the relationship between capacity loss and gradient. So from first graph we can show that when we increase the radius, the capacity loss will be decreased, and from second graph we can show that we can see that when we increase the value of gradient, the capacity loss will be decreased. Now come to the conclusion part. So our first conclusion, we find the values of capacity values on the curve stretch and the tangent stretch. So we got the values of capacity tangent portion. Values of capacity were tangent portion on high and then the curve portion, and the capacity range of on the tangent portion was 652 PCO per hour to 2409 PCO per hour. And from graph we stabilized, we can see that the effect of gradient of tangent on the capacity, when we increase the value of our tangent gradient, then the capacity will be decreased. And now come to the next conclusion, the relationship between the capacity loss and between geometrical characteristics. So firstly was radius of radius. So when we increase the value of our radius, then capacity loss decrease. And when we increase our value of tangent gradient, the capacity loss also decrease. Then it means when we take a larger curve and the steeper gradient, then the capacity will be low. And here are the some limitations of our work. Like our study mainly focus on our study mainly for two-way two-lane roads and for hilly regions. And if we take a more number of sites, then we can get accurate values of our sites. And like if there are any software which can if there is any software which can give us directly values on curved roads, then we can get direct speed values. So this, thank you.
Thank you, Mayank, for keeping your presentation in time. Just a small clarification. So your study stretches, were they in urban areas or outside urban area limits?
Outside the urban areas.
Outside urban
Yes,
area
sir.
limits. Okay. We have time for a few questions. Yeah, please.
So when you looked at the binding constraint on these roads, was geometry really a binding constraint? I know that geometry is linked to the speed and the capacity,
Yes, sir.
but in our when we go to the hilly areas, there are lots of other factors that control speed.
Yes, sir.
So was geometry really the primary point, or were there other factors that were very significant, even in the non-urban areas that you were looking at?
So actually, we just taken the main key features which were affecting the speed. Like there are many, or there are other many features are there, but mostly those we were taken just those geometric features that were mostly affecting our speed.
No, but what he is asking is, did you try to eliminate the effect of, while selecting the study stretches, did you try to eliminate the effect of other influencing parameters?
Yes, sir.
While trying
So
to study these geometry parameters?
So when we calculated our capacity, after that we were applied some adjustment factors for those purposes also, like for shoulder width, for lane width,
So
to estimate the adjusted capacity. Yes, sir. So actually we took 4 sites. So whatever site we took, that was almost same type of sites. So we neglect that effect.
I think one more factor could have been the climatic condition. During rainy days, if you would have conducted your surveys, you would have got different result when compared to the non-rainy season. Those are seasonal factors also. Which
The weather-related factors as well. Any other questions? Any questions? Okay, thank you.
So much, sir.
So I'll quickly call the next author, Yash. That's paper 47 on station area planning for mass transit in India. Discussions for the Indian context. 10 minutes.
Good morning all, this is Yash from Beyond Urban. One of the areas where on which we work upon is sustainable transportation, and today I'm going to talk about station area planning for mass transit in India, discussions for the Indian context. Firstly, I'll talk about a few terms which will be frequently used in the presentation, then I'll introduce the topic followed by certain aspects that we studied in our research, and then finally what could be done to improve the situation, the problem that we have identified, and finally why this study is important, and talk about the results and discussions. Firstly, the TOD or transit oriented development is a very spoken about topic nowadays, which is basically a very densely planned mixed land use, and one of the aspect that it considers is area of influence, also called as influence zone or local area or station area, which is basically an immediate area in the vicinity of a metro station, to support the basic needs of the residents nearby. And planning of such areas is called station area planning, and catchment area of a metro station is a different connotation for area of influence, where we talk about the number of people that the metro station attracts as non-transferring passengers. We all know that the number of cities where metro is been planned is growing, and around 14 cities have existing metro, and around 8 cities have metro network under construction, and around 30 cities there is a proposed plan for metro. And that is why Ministry of Housing and Urban Affairs have brought in this policy of national policy called National TOD policy in 2017, which explicitly talks about station area planning and TOD. And it talks about of having a half-mile circle around the station, approximately 800 meters of radius. And the basis of this figure is the walking distance, which is comfortable for the people. So the question that arises during our research is replicating this figure of 800 meters, which is usually borrowed from studies done in developed nation, appropriate for the context of India? That was the main question that we tried to answer in our study. So we studied the different ridership in different metro cities where metro is already ongoing, and we observed that the planned ridership or the estimated ridership that we took from the DPRs of the projects was much higher than the actual ridership that the city is taking in. Then we studied the national TOD policy that came out in 2017, which defines what a station area is. So basically, a walking it's an area in the immediate vicinity of a station area within the walking distance. Then it says that it ranges between 500 meters to 800 meters, basis of which is the comfortable walking distance of approximately 10 to 12 minutes of walking. And it also suggests that these areas should be indicated in the master plan as local area and be planned further as local area plans. Then we tried to study the scenario of walking in India and how is it related to station area planning, for which we used the data from census 2011, which gives data on the percentage of not percentage but the number of people who walk to work, and it also gives different distances that they walk. So we observe that a significant amount of people walk to work in the cities where there are metro networks planned. And we also observe that there is a significant correlation between population density and the share of people who walk to work. So basically, denser cities have more share of people who walk to work, which is the basis of TOD. Next, we try to understand that the distances that percentage of people who walk to work. So using the census data, which divides the percentage of people who walk to work between 0 to 1.5 kilometer, 1.5 to 5.5 kilometer, and 5.5 to 10 kilometers. So we observe that the percentage of people who walk to work more than 1.5 kilometers is highly significant. Out of 11 cities that we studied where metro is there, 8 of those have more than 50% share of workers who walk more than 1.5 kilometers to work. So it directly questions the figure of 800 meters as walkable distance that is globally considered as a thumb rule. Then we try to understand, is diversity also a factor in Indian cities that could be considered to plan our local areas? So variables like road density, vehicular ownership, and percentage of people who walk to work were considered and can be seen, and the Pearson's correlation can be seen that it is highly significant. And also from the scatter graph, you can see, scatter plot, you can see that population density has strong relation with vehicular ownership as well as road density, which are some variables proxy to the diversity of Indian cities. Then what can be done to cater to this problem? So we think first we need to sensitize the local governing bodies about SAP and the benefits that can happen because of SAP, and a context specific demarcation of an SAP or a station area. And next would be to baseline that by doing surveys very specific to the context or the local area, to understand the local behavior, the ridership pattern in that area. And this survey would have potential to get incorporated in the comprehensive mobility plans, which is mandatory for metro cities to have that, which can be updated in every 5 years. And next, using this survey, we can demarcate these influence zones around each metro. And this demarcation should not be based on some thumb rule, but surveys done in that specific area. And finally, incorporation of aspects like optimized density, mixed land use, and parking management can be incorporated, which are some of the key aspects of a TOD. Next, we try to understand the importance of a context-specific expanse of a station area, wherein we took 3 metro stations along in the metro network of Delhi, which is Rajiv Chowk, Rajouri Chowk, and Shastri Nagar metro station. So out of these 3, firstly, all the 3 have a very different morphological pattern in terms of built area, in terms of open area. And then we took one station, that is Rajiv Chowk, and demarcated different area radiuses of 800, 1200, and 1600. Now, if we increase the radius from
Yes, 2 minutes.
Yes. If we increase this area of radius from 800 meters to just 1200 meters, that is around 50% increase. We increase the area of influence by around 220%, that is 2.2 times. Now planning of jobs, housing, schooling in this area can be done in terms of TOD, and this will reduce the reliability on private vehicles and more reliability on public transport and walking, which is the main purpose of a TOD. And this will also increase the land value, the revenue in the area, and bring opportunities closer to the station. Now, the key findings that we did was that metro ridership in Indian cities is observed to be very low, and the willingness of people to walk is more than the usual thumb rule of 800 meters. And recognition of diversity or heterogeneity of Indian cities need to be incorporated in planning these areas. We understand that the sample size of the cities was low and it was limited, and also psychosocial dimensions were not considered in the study. However, the study is ongoing, and we are planning to build up this study further. Thank you.
Thank you, Yash. We have time for a few questions. Yeah, please.
I would say interesting topic, but lot of questions in that. The first question, and I'm going to go nitty gritty, just the basic question of the analogy of what you said. People walk 2 to 5, 6 to 10 kilometer, very high percentage. It's very interesting to note that, first of all, I'm not very sure whether this data is really reliable. I mean, frankly, the mobility, no, even the census data, mobility, it's all enumerators. Let us look at that way. But even assuming if it is correct, then my presumption is that these people are poor. These are EWS section, and the EWS section is not a rider on metro. So the context transposition on the general city behavior to metro TOD, that analogy is wrong. Are you getting it? If one were to transplant it, then the best thing would be to do an empirical data of first and last mile on current operational metro systems and find out how much people walk. And it's not you see, there is also, its TOD is not only the walking part of it. TOD is all about the economics around the station. It's about densities. There is a decay function, the Delhi TOD where I was involved as part of the master plan. You have the 800, 1200 and 2 kilometer. You also have till 2 kilometers. It's not only 500, 800. There are transition zones where you have the circulatory system which come in, not only walking. So I think as a researcher, it's a interesting topic to probe, but don't conclude by immediately that this should be like that. You need to kind of do some more work on that. Thank you.
I think one aspect is, walk as a main mode versus walk as a access and egress mode. The distance that people are willing to travel is totally different. Yeah. So yeah,
Quick question.
please.
Did you do any work to the point that was just raised on the economic distribution of the people that were walking? Did you have any insights on that?
No,
No.
sir. So
You
the
just
aim-
looked at walking.
Yeah, so the aim was not to understand how much people are walking in each metro station, but the data that we presented kind of points that the willingness of people to walk is much more than the thumb rule that is considered, and not to understand what exactly how much people are walking in each metro station.
And what was the source of your data?
Census 2011.
Okay.
Any other questions? Yeah, please.
In metro system, when we design stations in CBD area, we usually construct the station where the space is available. That is the most important factor, rather than how people come there.
Yeah, I know. I mean, that's the practicality of it, but that's not the best way to identify the station. I understand your point.
But then after you've gotten that location, we are still densifying our cities. The future densification and the future transit-oriented development can happen around that new area.
Yeah, I know.
To note that how the underground station versus overground station perform in terms of the walk trips, whether people prefer to use more of underground versus elevated stations.
I mean, of course, there's a cost difference in underground and elevated, but my take is, any core city area, CBD, not the CBD, the core city area, which has historical relevance. I think these subway systems, the metro system should be underground, in my opinion. I mean, you see metro systems across the world, barring Indian cities, you would find the core city areas, these metro systems are all underground so that you preserve the heritage and historical part of the city and don't destroy the aesthetics by creating elevated structures. So, but then probably it's a matter of discussion in some dedicated session. I know. So, yeah, I mean, all elevated structures, they're destroying the aesthetics of our Indian cities. Any other point? Okay. Thank you.
Thank you.
Thank you, yes. Is Harish Kumar is present? No. Vaishnavi Gikani? Vaishnavi? No. Then Adarsh Yadav? Adarsh Yadav, analysis of traffic noise annoyance at intersections in mid-sized Indian cities.
Good morning, everyone. My name is Adarsh Yadav, and I'm working as a PhD research scholar in the Department of Civil Engineering at IIT Roorkee. I'm here to present on the topic of analysis of traffic noise annoyance at intersection in mid-sized Indian cities. So basically, I will start with the introduction part. What is noise? Noise is basically defined as unwanted, undesirable, and unpleasant sound. And noise basically costs around 0.2% to the overall GDP of a country, according to WHO data. And basically, as we can see in this figure, there are multiple sources of noise such as railway, road transport, airport, construction, as well as public announcement. But road traffic contribution is like more than 70 to 80% to the overall urban noise. And this problem become more serious at intersection as per the study conducted by the Koen Batulwar and his team. And so as we can see that the major noise in the vicinity of intersection is due to the traffic noise, and the traffic noise is basically impacting the health of the urban dwellers, and it is basically like causing discomfort as well as it is leading to the mortality also. And the major problem experienced by the urban dweller is annoyance, which is basically like defined as discomfort or disturbance experienced during the different activities. And annoyance can lead to many other like serious health issues such as cardiovascular diseases. So as per the WHO data, traffic noise can only explain 20% to the overall traffic noise induced annoyance. So we can see that there are other factors also that are affecting the traffic noise induced annoyance. Based on the literatures, like I have proposed some hypotheses like such as psychological, like gender, socio-demographic factor is affecting the annoyance, which like includes gender, age, income, and education. And the other factor is noise sensitivity, which basically a personal trait and varies person to person. It is also affecting the annoyance. And next is traffic noise level. It is having the significant effect on the annoyance. And again, the last one is the noise exposure hour, which is affecting the annoyance level. Based on the proposed hypothesis, like I have collected data in Kanpur city, which is typical mid-sized city. Total 15 intersections have been identified in the locations from the different land use, which is shown in this table. And data is collected like within the intersection influence zone, which lies basically 250 meters from the intersection stop line. And data basically basically surveys conducted at each locations, and data is either directly asked or data is measured on a 5-point Likert scale. The total 487 respondents participated in this survey, and like this table basically depicts the data which is directly measured, such as gender, age, income, education, and exposure hour. While traffic noise level data is like measured using a sound level meter near the intersection locations for the 342 hours at 342 hours, and the other one like the data that is measured on 5-point scale using a not at all, slightly, moderately, very, and extremely scale. And the noise sensitivity and annoyance is basically measured on the 5-point Likert scale. Annoyance is basically measured in the different parameters with like different disturbances experienced during conversation, reading, resting, sleeping, using phones, watching TV, and working. And for the proposed hypothesis, to confirm the hypothesis, basically I have used a PLSM model, and PLSM basically includes two components, which is basically measurement model and structure model. And first measurement model is performed, and the measurement model performance is checked based on the indicator reliability, internal consistency, conversion validity, and discriminant validity. And second, structure model is performed. The model performance is again checked based on the p-value, r-square value, and VIF value. And based on the measurement model analysis, total 14 indicators are identified under the 8 constructs, and which is shown in this figure. And as we can see that the indicators loading are greater than 0.5 for the each factors. So this confirms that the measurement model has achieved the indicator reliability, while CR like Kronbeck alpha and composite reliability value is also greater than the recommended value, which confirms that a model has achieved the measurement model has achieved the like satisfactory criteria. Again, the AV value and STMT value is greater than 0.5, which is also confirming the suitability of the measurement model. Further, structure model analysis is applied to check the path relation of each factor with the annoyance level. And as we can see that the R-square value using this factor is greater than 0. Is equal to 6.9, which indicating that the model is having substantial explanatory power, as well as the VIF value, which is basically used to check the multicollinearity issue, which the VI value is less than 0.5, again confirming that there is no multicollinearity issue. So based on the PLSM analysis, we have identified that gender, age, and income is having no significant effect on the annoyance level, while traffic noise level, exposure, or education as well as noise sensitivity is having significant effect on the annoyance level. Based on that, as we can see that in table, that noise sensitivity is having the highest impact, and it is responsible for the more than it is responsible around 49.9% annoyance experienced by the urban dweller. Like if they're people who is having who is highest who is having highest sensitivity to the noise is experiencing more around 49.9% annoyance compared to the people who is having zero noise sensitivity, while education and exposure hour is having around causing 25.4 as well as 18.5% increment in the annoyance, and traffic noise level is causing 18.2% variation in the annoyance level. So based on the study conducted, we can say that age, gender, and income is not having any effect on the annoyance level, while education is causing a significant effect. So for proposing any measures to control the annoyance level, education level should be considered, as well as the criteria which is having the significant impact is the noise sensitivity. So this factor must be considered while shaping annoyance mitigation measures. And traffic noise level has also obtained that it is having significant effect. So this parameter should be considered, and based on the conclusion, we can suggest that the traffic noise level is the major cause near the intersection, which is causing the traffic noise, which is increasing the traffic noise level. So to control the traffic noise level, we can propose the efficient public transport system should be implemented, which will reduce the traffic volume, overall traffic volume, as well as it will cause a decrement in the noise level. And second is the we can recommend to implication of the noise reduction measures, such as construction of the noise absorbing pavements, as well as we can propose some effective barriers. And the noise sensitivity, as we have seen, is one of the major important parameters. So our initiative with the interventions should be noise sensitivity. We have to conduct survey to identify which area is having highest sensitivity, where higher noise sensitive people are staying, and the priority should be given to that locations to control the noise mitigation techniques to reduce the annoyance level as well as other health effects. And from this, by this I am concluding my speech here. Thank you.
Thank you, others. Any questions from audience? So if not, two presenters are not presented, so this session is closing now. You can attend parallel sessions in Asoka Hall, Talwar Hall. Thank you.